Alright, so vectors in r squared and r cubed, 1229, that's the code. Alright, so now what is the meaning of r squared? R means a real number, right? The collection of our real numbers. And most of the time they represent it with a line, right? The 0 in the middle, and then 1, 2, 3, 4, and so on. And we have a negative integers and negative real numbers. Like this number is negative half, negative 1/4.
Is it still a real number? If
Yeah,
it's negative?
we call it real line,
Okay.
just a one real line. So it's a one-dimensional geometry, right? Just a one. Now we can talk about the 2D, which is going to be similar to that, but it's extension of the 1D. So we have to open one new dimension in order to talk about r squared. That means two dimension, like a surface. So this surface that we have right here is a 2D surface, right? And now, what is the meaning of 2D? What is the difference between 1r and r squared? In a 1r, we have just a one direction. That is that, right? We can go in this direction. But in 2D, we can move around. We can move like there, right? Like here.
Right.
So we have curves in R2. So anyways, let me give you a quick example. For example, if your car is parked, this is a wall. Let's assume hypothetically this is a wall. And your car is parked like 1 kilometer, that is 1 kilometer away from this wall. Now, your car can lie anywhere, right? Its position can be anywhere. But in order to give the exact location, I have to give you the distance from this wall, right? Let's say I give you that the distance from that wall is just 1, right? 1 kilometer. And from this wall, which is the y-axis, the distance is 3. So the coordinates we write 1 comma 3. I think you're already familiar with that.
Yeah.
So we have two dimensions to locate the position. So now in vectors, if you meet this point with the initial, now this point is the initial point, the 0, 0. That is the center of r squared, 0, 0. If I meet a vector which is originated from here and it goes all the way there, like let's say this thing. So this vector is indicating that position, right? So we call it vector. You can call it u, v, or whatever, or you can call it o. This point is a, let's say. So OA is a vector. So they're going to use,
Like the whole line that we're looking at?
yeah, this whole line, this indication. Now we know that there's a length of the vector, which rely on the length of this side and length of this side.
So where the arrow is where it actually stops?
Yeah.
It doesn't
So
represent it like continuing?
no, it's not. It's just
Okay.
kind of a segment. It's starting from here, ending right there.
Okay.
So uh, some people they call it head and tail, but it's like initial point, ending point right there. So we don't have to go that deep. So it's just a line. So the vector is a quantity which is having a direction. Now we can measure the length of this vector just by using Pythagorean theorem, because this is the height and that is the base of this triangle that we have right here.
And
So
it would always have a right angle because...
yes, that's true, because we have now the reason why we have a right angle, because this line, the y-axis, is meeting x-axis at 90.
Right.
They meet at 90 degrees, so obviously any vertical distance, so this angle is going to be 90 degrees. So always it's 90 for any point, for any coordinate. So the vector is OA, and its length is going to be, let's use Pythagorean theorem and figure out its length. So OA squared hypotenuse squared equals to the square of this side, square of the small sides, right? This side is 1, so they call it a squared equals to b squared c squared. But you have to remember it this way, it's going to be more easier. The largest side square equals to the sum of the small sides square. Now this side length is 3 squared. So largest, and there we have smaller sides, the sides which are small. And how do you know that largest side is hypotenuse? Because the largest angle in this triangle is 90. They are smaller than 90. So the angle 90 is going to give you a side, like opposite side is going to be the largest and hypotenuse. Now we just solve that thing.
It's kind of a weird spelling.
I know, but it's a unique name. All right, Maddie. We do square root of 1 plus 9, and OA whole squared. So 10 OA squared. Now, in order to get rid of the squared, we do square root on both sides, and square root cancels the squared. It's kind of opposite of that. So this is the length of that vector that we have right there. You can write it there. This is the length of the vector. Now we will talk more technical aspects of that. Let's go back and make one more reference plane there. All right, so let's assume we have 1, 2, 3, and positive 1, 2, 3, negative 1, negative 2. That's enough, I guess. Negative 1. Now, any point on this reference plane, any point, can be anywhere, can give rise to a vector. Any point. How it's going to happen, for example, if I pick this point, I'm picking some nice points so that we can understand it more deeply.
Does it always have to connect to the middle?
Yeah, it's always position vector.
Okay.
Any point, this is the origin, so any point create or give birth to a vector. So if I meet this thing, let me use this arrow there. Now that is a vector.
Okay.
And the point is quite obvious. We write the distance on this line, right? That is 2. And then we write distance on this line, which is 3. So 3. So this is the vector, and you can call it UV. In this course, they're going to use these symbols, U vector, V vector. You can name it whatever, or simply you can call it A, O, and this is A, B, C, whatever you want. So OA is a vector, and in this course, they use open brackets. But there are many other courses where they use this special kind of bracket for vectors. But in your course, it's gonna be written as a point. So this point is a vector on the same time.
Okay.
Good. So every vector has a direction and magnitude. Magnitude means length, right? Let me write it down here.
So if you had a vector over here, like, would you just put a negative sign in front of that?
In this direction?
Yeah.
Good. I'm gonna talk about that. Let me write down this thing. So my u vector is 2, 3, and its magnitude or its length. We use this symbol for that. We put 2 bars on the right hand side, left hand side, like double mod, right? So that means the magnitude, and that means magnitude. Magnitude means the measure, the length. So magnitude means scalar quantity. So vector is having 2 things. Vector has 2 properties. Vector has scalar quantity or the magnitude, scalar property. Scalar means just a number, and direction, right? Though the scalar, now what is the meaning of scalar? Scalar means, for example, just a distance, right? Now if I tell you that Masonville is 3 kilometers, now I'm not giving you a direction, just a distance. So distance is a scalar quantity. And speed. Now, if you're driving normally at 60 kilometer per hour, you're not giving me a direction in which direction you're going, just a speed, right? So these are scalar quantities because they have only magnitude, right?
Okay.
And let me, I can give you more examples, but I think it's enough. They have only magnitude. That means the measure, only the number. So the numbers are only numbers are attached to those measures. For example, 2 meters or 20 kilometers per hour. So they are without direction. The
Right.
time I give you the direction, these quantities turns into the vector, right? So how we give the direction, we make a point and then we make another point and then we tell this distance. And now this distance is known as displacement. We call it displacement, right? That distance. And if I tell you or you tell me that I drive on this road at 20 kilometer per hour, then this is gonna be a vector quantity because you have a direction, and we call it velocity. In physics, instead of using speed, they use this word velocity. Why do they use this new word velocity? Because velocity means a speed in a specific direction, right?
Okay.
So now you understand that vector is having these properties and a direction with them, right? That's why they're unique. They're not like the scalar quantities like these. They have something more than that. There's a direction. So now, why we have the studies of vector? There's a lot of YouTube videos you can watch them. Like why do we need them? I'm gonna explain to you all those things very quickly. Um, so the vectors have a direction. In order to study some physical aspects or physics aspect like the force. Now, the force is a vector quantity because whenever you do apply a force, you give a direction. Like let's assume there's some object, and now if you want to move it in a certain direction, in this direction, so you apply force and on the same time you have a direction, right? Let's say this is 2 Newton force applying in that direction. So the vector associated with that, you can say this is my 2 Newton, right? And if somebody else apply a force on this object from this direction, that means it's gonna move in this direction now, right? Let's say this guy is applying 1 Newton force. So 1 Newton force and 2 Newton. Now if you, instead of using this thing, I use these guys, because they look more better. 1 Newton, that's 2 Newton. So can you tell me in which direction this body is gonna move if both of them apply force on the same time?
Closer to this one, but kind
Very
of in
good.
between.
You know math. So it's very pure logic. It's gonna move closer to that one. Did you study some vectors by yourself before like doing this session today?
No.
No? So you understand it better. I think you are a vector girl, so probably not a probability girl. Some people they do really good on this course, and some they like more practical ideas. Now we know that this force is this is the resultant of both of them. But how long is gonna be that? This is the question. Let me give you answer for that. I erase it. Now the resultant of 1 Newton and 2 Newton is gonna be in the middle of that. And it is gonna be the diagonal of one of the diagonal of the parallelogram. For example, if I draw a parallelogram like that, this diagonal is representing the sum of these two sides. So the force, this force, which was originally right there, you were pushing, and there's another guy. So instead of studying them, we study the effect where the body is moving.
Okay.
So this, let me call it u vector, and the another one v. This is my u vector. That is v vector. So this resultant is the sum of them, u and v. So I'm just teaching you geometrically. We're gonna do a theory of that and how in real life these things are gonna work. So that was one of the example of the vectors where we use them, and so there are many examples that you can find for the vectors. So the usage, or why we needed to invent a new branch of science or mathematics. So they use vectors in all sciences, and even in some applied. Most of the people like do that thing in applied natural sciences and applied social sciences. They do those studies, and even in businesses, I don't know, but they do that.
Okay.
Now the next thing is we will study the sum and the minus, the subtraction of the vectors. So let's say this is your u, and the v vector is right here, right? That's the v. Um, X is 2, y is -1. So the vector is going to be right here.
Okay.
Right? So the sum of u and v, according to that law that I taught you, the parallelogram law, it should be the diagonal of this parallelogram, right? Which is gonna be right there. Make sense to you? So this is u plus v. Now this is a vector basically because it's meeting right there on this corner, and 2, 2, 4, and -1 plus is gonna be 2. So somewhere here. So if you look at that, it's 2, and that's 4. So 4 first and then 2. So u plus v is 4 comma 2. Let me write down all of them. We were writing it here, but let me write it here now. So your u vector is 2, 3. V vector is 2, -1. And u plus v is no need of bracket. It's the sum of corresponding coordinates. 2 plus 2, 4. And the sum of that is 2. And that's what we got there.
Okay. So when you do this, like, do you just use a ruler to try and make it parallel when you draw the
Yes,
lines?
like we will not be doing a lot of geometry, but I'm teaching you with the pictures so that you can, visualize those things. We
Okay.
will be doing these kind of things,
Okay.
not the geometry. That is just to understand, because there's one unit which is completely geometry kind of based on the geometry 1.3, and most of the students fail to understand that topic.
Okay. So
And
instead of like finding this point, it would give it to you?
yeah, they're gonna give you those points.
Okay.
These things are gonna be given. We'll do some questions related to that. Now we already learned how to find the length of any vector. For example, the length of this vector, which is the resultant, which is the sum of u and v. Can you suggest me the way to find the length of this u plus v? So the magnitude of u plus v, let's do revision of the same concept that we did that right there. The magnitude, right? We were doing it there, basically, right here,
Oh, okay.
right? So by using the same logic, we do add the base. So square root of the largest side, which is this thing, right? The square root of this side, which is the sum of u and v, equals to the sum of the squares of the small sides.
Okay.
This is 4, and that
That's
is 2. Yeah, the y distance is vertical is 2, horizontal 4. So 16 plus 4, 20. So that is 20. Now we do square root on both sides. So the length of u plus v is square root of 20. And we know we can break it down if you want to make it simplify. This is acceptable, but if you're good on high school math, we break it down like that. Now we do square root of those numbers separately. Square root of 4 is 2. Square root of 5, we don't know, right? So we just keep it like that.
Okay.
So this is the length of, or the magnitude of, the sum of two vectors. Now those vectors can represent a force, velocity, anything. So this v was representing something. So its length was this much, and u was representing some other kind of force or velocity. Now let's assume there's an object right there, and we assume that this is v and u are forces. And if you apply these forces on this object together, then this is gonna be the resultant movement. Good?
Yeah.
All right, so we now I talked about r2, r cube. In the same context, we can make a vector in 3D plane. Let's complete that thing here as well. I'll text you those slides. Let's do it in, you can go over those slides later on. The video will be on YouTube channel, and these slides I'll email you all those slides.
Okay.
Now, in 3D, 3D. All right, so we have a 3D plane there, and let's assume this is my x-axis. You can name any one of the x's. We have one axis, second and third, 3 x's, right? So that's my x-axis, and I call this is my y-axis, and that's a z-axis. Now in this diagram, we have this is the floor. It's hard to, I think you can imagine this thing. This floor, that's the main floor, and that's the basement down there. And up here there's a roof, right? The space going up. So this is the plane, we call it XY plane, right? XY plane is there. And the height, when you add height, that's gonna be a 3D plane. So this is a real line, that is also a real line, and the third real line is a height. Now they're not on a surface, but in a space. For example, let me give you one example. I assume that's the positive side. You can consider any one of positive. I consider that one positive 1. This is 1. That is 2. 3. Now, let's make a point. Now, here we have 2x, and the y is 3, right? That is in 2D. In order to convert into 3D, we have to look at the height, and there will be a component. Let's assume its height is this much. Now this point, we lift it up. We pluck it from the ground and place it in the air. So the x is still 2, y is still 3, but the z is not 0 now. We are not on the plane, we are up here, and it's gonna be 1, 2, height looks like 2, right? So let's say this is 2. So that's kind of height of that. I think I passed. I should go back a bit. Yeah. Yeah. This is the height of that, approximately. So now the vector is gonna start from there and it meets right here. So this is my vector 2, 3, 2. Because the height is also 2. Right? So they're in 3D. Can you imagine that thing?
Kind of, yeah.
Yeah, so for example, on this book, x-axis, let's say this is y-axis, z-axis. So if any point is there, you can make a vector. For example, this point is going to be this vector.
Okay.
Right? If they're on a plane, they will be just lines on the plane, on the surface. In 3D, they're going to be like that, in the air. Right? Now, the same concept for finding the length of the vector. So the vector length, I call it, let's say this is u vector, and let me write it down here. Vector u is 2, 3, 2, and the length of u vector, or the magnitude, is square root of all those components. It's like extension of the Pythagorean theorem. So we have squared there normally, and then we do square root. You remember that thing, right?
Yeah.
Yeah. So we were doing for 2 component, now we're doing it for 3 components. Now we just expand it. 4, 8, 8 plus 9 is 17. So when you solve that, you get the length of that vector. So the magnitude or the length we can find with the same way. We squared all the sides, like we squared the 2 squared this length, which is 2, and then we squared that length, then the height, and we add all of them, then do the square root, and that is gonna be the length of the u vector.
Okay, so the square root of 17 is the red one?
Yeah, red
length
one.
of it?
Yeah,
Okay.
that's so this u vector, it has a direction, and its length is that much, or its magnitude is that.
Okay.
So we call it magnitude. Let me write it there. It's a magnitude. How many lectures do you have today?
Pardon?
How many lectures do you have today?
I didn't have any. I just worked this morning. I started work at 6:45,
Oh, okay.
so I'm kind of tired.
Oh, that's why
Yeah, I
I
had to get
saw
up
that.
at 5:30.
Wow. But anyways, the videos you can watch it later on, and polish your concepts.
Yeah.
So that's the 3D thing. Now, in the same manner, we can add the vectors in 3D as we do in a 2D. For example, if u is 1, 1, 2, v vector, normally they use the arrows, but in your course they don't use. They just write a kind of fat u, a bold v. So, but this is a common practice. We always use arrows in rest of the vector courses. So 1, 1, 2, then we have 1, 0, 1, let's say. That's v. Now we can add them, and the sum is gonna be exactly like 1 plus 1, 2. Y components add up, and then a z. This plus that, which is 3. So that's the sum. So the vector that we have right there, they can give you a couple points, like they can give you a u and v, and you can add them up. So for example, I make a 3D space quickly there. So if you have a u, u is 1, 1, x is 1, y is 1, and that is 2. It's gonna be somewhere here in the air. And sorry, yeah, that's the resultant. But 1, 1, 2 are the vectors, right? Somewhere these are the vectors 1, 1, 2, which is gonna be 1, 1, 2 here, and the another vector is 1, 0, 1. X is 1, Y is 0, and Z is 1. So somewhere here. So we have two vectors, and like some vector here. There's another vector right here, and their sum is gonna be the resultant right there, right? In a 3D. So in 3D, if you have this vector and that vector, the sum is gonna be in the middle as well. So, but we will not talk much about 3D in 1.3. Now let's talk about the ideas and concepts more slowly, because we went through a lot of concepts. Let's do some practice. You open the magnitudes of
Like to homework questions?
that is that. Now the first thing that they're talking about, the equal zero vectors. Let me explain to you, so we'll be following that. Now, two vectors are equivalent if they have same length and same magnitude. Let's say this is my vector u, and I name it v some vector right there. Now u and v are exactly the same vectors. They're just a clone. They're copy of each other. Why? Because we have same direction and same magnitude. So if you have same magnitude or length plus same direction, same directions, then we call them that they are equal or equivalent.
Right.
So we can replace any one of like u with v or v by u, and you can move the vectors, like the numbers, they are just numbers, right? And now we have a direction. You can move this vector anywhere. For example, let me give you one example quickly, the meaning of moving them around. If you have a vector there that is 1, 2, and let's say there is another vector which is -1, -3, right? Now, how can you add them? In order to add them geometrically, you move it. You just draw it right there. You bring it right here. So the whole vector is gonna go here, exactly parallel to. So you just replace it there, and you still call it. That's the meaning of equal. This vector, you can move it anywhere. So the sum of these two is gonna be the resultant right there. Now let's make the resultant. The resultant is gonna be this diagonal of this hypotenuse. This diagonal of the parallelogram. And how do we add them? Component wise, 1 minus 1 is gonna be 0, and 2 plus minus 3 is -1. So that is the sum of those two vectors. So that was u, this was v, so I move it right there, then I added them up. So any question, Maddie, up to this point?
I think for the most part, I like get the concept. I think I just have to practice a bit.
Yeah,
to
you have to
remember
do
the
practice
steps.
for sure. Now let me talk about the unit vector and zero vector. Now when we call a vector is zero vector, zero vector means magnitude is 0. Now if I say I have a vector which starts from some point and goes, let's say it goes right here. Now we have magnitude, let's say this is 3 centimeters long. Now if you diminish its its length, it's gonna be just a 1 point if you just erase it completely. No length, we are making it shrinking, right? Eventually it just become lengthless. There's no length, no magnitude. Direction is hidden there. Still we have a direction, but it's hidden on a point. So this kind of vectors, we call them zero vectors. So for zero vectors, the magnitude is zero. And the magnitude, we use those bars on both sides. So magnitude is zero for zero vector.
Okay.
And now the next thing is unit vectors. So zero vector was that. Now unit vector. Now what is the meaning of unit? The literal meaning of unit is like one, right? Singularity,
Okay.
or one, identity. So we write unit vector. So these are really important. They use it a lot in applied sciences. And they use this symbol for that, unit vector of u. Now, I assume that this is my u vector. So u vector has a length. Let's say its length is, hypothetically, we assume its length is 7. Now the unit vector of u is going to be a vector which is really tiny and having length 1. This is the unit vector of u, and we call it u hat.
Okay.
And sometimes it just write unit vector of u. So what we're going to do, what we have to do in order to find a unit vector of u, we just divide its length by 7. So this is a u which is having length 7, right? This is the length magnitude.
Okay.
So we divide it by its length. What we left with a vector with length 1. So this u hat is basically equals to, I should write, let me raise it because we are using hat. So basically unit vector of a vector is the vector divided by its length. So unit vector of the vector u is a shrinked version of the same. So how much do we shrink? Until its length is 1, identity. So yeah, we just find the length and divide it by its length. Now let's do one example in order to understand it more better. But I think you got the idea there. So the unit vector is a vector divided by its length. So unit vector of u is that. Now let's do one example. Let's say my u is 2, -3. So I have a vector in 2D, and we know how to draw and imagine it in 2D, right? We can do that quickly in order to understand it more deeply.
So is the first thing finding the length then?
Yes, that's
Okay.
right. So 1, 2. -3 is gonna be right there. So it's gonna be in the middle. I mean, corresponding to both directions right there. Right? So its length is gonna be the squares of the components. So let's do, this is my u vector minus, 2 minus 3. So the length of this vector u, or the magnitude, equals to squares of both of square root 3 and 2, sum and square root of that. So 4 plus 9 is 13. Right? So I know the length of u vector, the magnitude of u. So the unit vector of u vector, unit vector of u vector equals to u vector itself divided by its magnitude, which is that.
Okay.
Now, most of the time they're gonna write it like that. A number outside, and you are allowed to multiply this number inside. They call it scalar multiplication. This number is just a length, and you can multiply that length with them. Now let's talk about how do we multiply them. But this is your unit vector, right? I can do that thing in order to, we'll finish it there, and then we'll talk about the scalar multiplications. So 2 divided by that minus 3, we insert that number inside, times it with both of them. Good?
Okay.
So that is the unit vector of u. Now we call it scalar multiplication. The multiplication of this guy with that, basically we're dividing both of them. So multiplying a fraction is equivalent to divide them by root 13. Any question regarding this thing, Maddie?
I think I'm good.
Good. Now, next thing. Scalar multiplication. Let's go to the next page and we'll talk about scalar multiplication. Scalar multiplication. Scalar multiplication of vectors, obviously. So we are talking in the context of vectors. So scalar means a number, right? Just a number, no direction. And multiplication is a common, word that we use for multiplying numbers. Now, what is the meaning of scalar multiplication? Let's say I have a vector this much, and this is u vector, and I assume its length is 4. Now, if somebody asks you to multiply it by 3 times u vector, now what does it mean? What's the meaning of 3 times u? That means you extend its length 3 many times. So its length is gonna be 12 now. The previous length is 4, so when you do 3 times, it's gonna be 4. 12. So we extend the length of the same vector. That's the meaning of scalar multiplication.
Okay.
So it's gonna be 3 times of itself. If I do 1 over 2u, what does it mean? Half of u vector. This is still a scalar multiplication. Scalar quantity is 1/2. What does this mean?
So just like half short.
Yeah, that's right. We make it half. So this is 1/2 of u.
So
And
the direction stays the same, it's just the magnitude that's
good.
changing?
This is just a magnitude. So scalar multiplication is affecting the magnitude or length of the vector.
Okay.
If you do 2u, that means you double the length of u. So 2u is gonna be this much.
Right.
Now the next thing which is important is about multiplication with the negative. That was your question 10 minutes ago. You were asking me a question with the negative. Let's say this is some u vector and going in this direction, and let's say its length is 3. Now if I put -1 in front of that u vector, that means I multiply this vector by scalar, which is -1. So how this -1 is going to affect the u vector? It reverses direction.
So it's kind of like a mirror?
Yeah, it reverses, that's right. It's just exactly opposite direction. It goes in opposite direction.
Okay.
Right? Yeah, so now how they really work, let me talk about that. We were talking about this example. Let me assume that u is -2, 3. And 2 times of u, that means double of u is going to be -2 times by -2 times by 2 and -2 times by 3. That means we just FOIL that thing, we multiply them. So negative 4 and 6. So this is your 2u vector. U vector was that. Good. So uh, now in this case, let's say this u or this vector, we can name them whatever you want. I'm using most of the time u name, but you can call them a, b, v, t, whatever you want. Now the u length, let's say u is 2, negative 7, and when you do negative u vector or negative, now this is the same thing. You can also write negative u instead of writing negative 1. You can just write a negative sign at the front. So, right? So this thing is same as that thing.
Yeah.
So this negative 1, or let me write negative 1, it looks more better.
Yeah, the one helps me. I just get less confused.
Good. So negative 1 times by 2, negative 2. Negative 1 times by negative 7 is 7. So we got a vector which is being multiplied by negative 1. So this is u, and negative u is that. Now, in next lecture, we're going to talk about how to add up the vectors geometrically, and how to subtract them, because we didn't do the subtraction of vectors. So right now we were just learning about these vectors, right?
Right.
All these kind of vectors which are originating from the 0, 0. And in the next lecture, we're going to talk about non-trivial, like these kind of vectors. This is a point, that is b. So we will talk about AB vector, and there's another vector, let's say there's BC vector, right? So how
the
we,
difference is that they don't connect to the point 0, 0.
yeah, like these are, AB are still made of the direction. Now A vector is that, B is this one, right? So they're still made of those vectors. So the basic vectors are position vectors. So maybe we call those vectors position vectors, the vectors which are originating from the 0, 0, all those position vectors. In this course, they don't use this word position vector because it's a really basic course, but we call them position vectors. And this vector is not a position vector because it's not starting from 0, 0.
Okay.
So I think we will finish it here, and I will send you all those slides,
Okay.
and I'll upload the video, and I'll mark a couple questions for you on the textbook. If you go to the problem section, the questions related to magnitude we can do. You can do it as a homework. So you can go to my website www.londonmathsolutions.ca, or just watch a YouTube channel. I'll send you the link, all right?
Okay.